Hello viewers, Centroid and centre of mass question 5. Find the centre of mass of this lamina as a short rectangle with a right triangle added to it. The rectangle has a density of 300 grams per centimetre squared and the triangle has a density of 400 grams per centimetre squared. So we'll go with a relative density for the rectangle of 3 and for the triangle we'll go with a relative density of 4 because that makes it a little bit easier to work with, but it keeps the densities in the same ratio. So this is a centre of mass problem, and our table is therefore going to have the two extra columns that we saw in question 3. So we start off with a lamina, then we've got the area, then we've got the relative density, then the mass multiplied by then x bar, and multiply those two to get mx bar, then y bar, and m times y bar is the last column. So the first lamina is the rectangle, and for this question let's work in units of metres. So the height is 0.5 of a metre, and the width is 0.6 of a metre. Area is therefore 0.6 times 0.5, which is 0.3, and the relative density of that shape, which is the rectangle, is 3. 0.3 times 3 is the area times the density, giving us the mass, which is 0.9. Let's take our origin to be the lower left corner. X bar for the rectangle is going to be half of 0.6, which is the width of the rectangle, giving us 0.3. M times x bar is 0.9 times 0.3, which is 0.27. And for the rectangle, y bar is half of 500 millimetres, half of 0.5 metres, which is 0.25 metres. And m times y bar is 0.9 times 0.25, giving you 0.225. Now we have the triangle, which has a height of 0.5 and a width of 0.3, working in metres. So your area is half base times height, is half of 0.3 times 0.5 is 0.075. Its relative density is 4. So our mass is going to be 0.075 times 4, giving us 0.3. X bar is, we're dealing with a right angle triangle here, and for a right angle triangle the centroid or centre of mass is 1/3 of the way along. So 1/3 of 300 is 100 plus 600, giving us 0.7. M times x bar is therefore 0.3 times 0.7, giving you 0.21. And for y bar, it's 1/3 of the way up, because it's a right triangle. Therefore, it's 1/3 of 500, giving us 167.167. We're working in metres. Okay, so m times y bar is 0.3 times 0.167, giving us 0.05. And there are only two laminae to this one. Let's get our totals. Our area we don't need, relative densities we don't need, mass we do. 0.9 plus 0.3 is 1.2. X bar we don't need. M times x bar is 0.27 plus 0.21 is 4.8. Don't need our y bar. M times y bar is 0.225 plus 0.05 is 0.275. And let's work out our x bar, which is the sum of the m times x bar divided by the sum of the mass, which is 0.48 divided by 1.2, giving you 0.4. And y bar is sum of the m y bars divided by sum of the m, giving you 0.275. divided by 1.2, which is 0.229. So our position of the centre of mass of this laminar is X bar was 0.4 and Y bar was 0.229. We're working in units of metres here. Thanks for watching. Over and out.